As we have seen the supervised methods, let us proceed to see the unsupervised methods in for word sense disambiguation. We already pointed out that supervised methods are higher in accuracy and the performance, but still one disadvantage with supervised systems is that for supervised system we require labeled data, that is manually annotated data which is not available for many corpus. So because we don't have labeled data, the obvious solution is going for unsupervised method. So word sense disambiguation problem is still, it is a problem of high intensity because we lack labeled training data. So to address that problem, unavailability of labeled training data or unavailability of manually annotated data. So there are different methods are used to address that problem. One problem is using clustering and to get sense induction. Then we can use proximity based sense selection. Then third one, bootstrapping method, seed growing method. So clustering, if you remember, and previously when you studied machine learning subject, we talked about clustering methods. And one of the most basic clustering algorithm is k-means clustering. We divide the data into k clusters and we assign the new point based on the distance uh, of that point to different cluster centroids. So here you require to specify the number of clusters before the starting of the algorithm. This is very simple and very effective unsupervised method. The second unsupervised method algorithm is hierarchical clustering, where you'll be merging small clusters uh, into a tree of clusters, or sometimes you'll be splitting that hierarchicals. For example, dog, hierarchically it belongs to animal. Similarly, there is a third group, DBS scan, density based spatial clustering, and this will based on how they are closely densed. The more density, it is more likely to join that point. We'll see it in detail in the coming slides. So another this is one method, sense induction. The second method is proximity based. That means the distance based. Even k-means is also distance based algorithm. So to measure the distance, Euclidean distance, cosine similarity, Jaccard similarity we have used. Now the thing is, we have to measure the distance between the word sense. How do we do that? That is another interesting aspect. The third method is seed growing method, bootstrapping method. What we do is first we start with supervised small, we'll take small manually annotated data, then we cluster those things and we do it iteratively. First we start with small amount of labeled data, then we will be expanding it with unlabeled unsupervised method. So when we talk about distance based algorithm, now we calculated the distance using the Euclidean distance. The distance between 2 points x1 y1 and x2 y2 is square root of y2 minus y1 whole square plus x2 minus x1 whole square. But we here in NLP, in the word sense, we don't have such x and y coordinates. We want to find the similarity between two senses in a resource like WordNet. Then the methods used are edge counting method. The second one is information content measure, and the third one is conceptual density. So edge counting method proposed by Rada and others, and it computes similarity by counting the shortest path. In dependency parsing, we'll be giving arcs to the head word. So how many edges are there? Now this method assumes that words that occur together, the distance will be less, like from the word net. So the limitation of this edge counting method is that in this method, they assumed that all edges are important equally, which is not realistic for complex hierarchies. So modifying that, Resnick and others have proposed another similarity measure known as information content measure, IC. So this method assumes that all the edges are not equally informative, and how it measures how informatic or how specific concept, how specific a concept is within a hierarchy. So the more specific a concept is, the more higher is information content measure, something like an entropy. So if you remember in entropy, if the entropy is more, there is no information available. If the entropy is less, the information available is more. If 5 are positive, 5 are negative out of 10, then we cannot take any decision. The entropy is more. Similar measure is information content measure, calculated by again the same formula that we used for entropy minus log PC, where P of C is the probability of encountering an instance in the corpus, how many times it has occurred. So we find the least common subsumer, something like for dog and eagle, rather than eagle, we can take cat because eagle is a bird. So dog and cat, the least common subsumer is animal. So we find that and we find the similarity. The advantages of information content measure is it provides a quantitative. It is not subjective. It is quantitative, and it is more effective than edge counting, because in edge counting all the edges are given the same weightage. But here the limitations are we require large annotated corpus and we assume static hierarchy, but hierarchy will be changing. Then the third one is DBS scan, density based spatial clustering of applications with noise. So this is a clustering algorithm used for identifying groups in data sets where points are closely packed. That means if there is more density, that group, there is more chance that given test point is assigned to that group. So effective for data sets with noise or outliers. Outliers or noise will be low densed, belonging to low densed area. So as in k-means, we need not specify the number of clusters beforehand. And in this algorithm, what we do is we calculate the radius within which points are considered neighbors. That is a group. If there are more items, we call that as a dense. Then the minimum number of points required to form a dense region. How many points? We will call it a dense region. So for each point, we'll check how many points will fall within the distance epsilon. And if the number of points are greater than minimum points, we will create a new cluster. And this is how clusters will be expanded. Then continue it until all the points are processed. And whenever a point comes, we have different points in this algorithm. A core point, a point with least min points within distance epsilon, border point, which is not a core point, but even within the distance epsilon of a core point. Noise point, it is far away from the dense region. So for example, if you have geographical coordinators of people in city, suppose epsilon is 5.5 kilometers, min points is 5. So densely populated areas, something like markets, hospitals, they form dense clusters. Isolated areas where the people will not be there, they will be marked as noise because they are located far away from this one. So the advantages, we don't require to specify the number of clusters at the beginning, and it can detect clusters of arbitrary shape, and it is very robust to noise and outliers. But the problem is the density of the clusters may be varying during the process, and when we have high dimensional data, the performance also degrades.